everybody. This is David Weiss. We're starting our Flat Earth debate with the paulestal service. Most of you probably know me. If you don't know paulestal, you can look at his channel, the paulestal service. I'm going to do my best to answer everything I can about the Flat Earth and the way I see it.
It's called sunset. You got this orb in the sky. It's called the sun. It's a big round sphere. And it goes down and it goes behind the horizon, and it doesn't just disappear on an infinite plane and become smaller and smaller and smaller into a dot above the horizon. It is huge. I mean, it's not huge, but it's very large as it goes down, and it never gets smaller and smaller and disappears like you would expect on an infinite plane flat Earth. It's just really that simple. You just watch any sunset or sunrise, the sun very quickly comes up from behind the horizon at the same size it is as it gets higher in the sky, and that's exactly what sunset and sunrise is. What's your explanation for that?
Well, this is where I'm going to keep it as short as I can, and I'll link videos to what I'm talking about, but I'll touch it. There's several things.
Yeah, keep it brief.
I'm going to keep it brief as I can. There's different atmospheric conditions, different weather conditions where you see the sunset. Sometimes you see the sun much farther. Sometimes it gets blocked out by a cloud bank, which is...
We're talking on a clear day, the sun. You see the sun go down.
So here's the thing, even on a perfectly clear day, over distance, the atmosphere builds up to a point where you can't see any farther. That's why you can't see across to England, or you
No,
can't...
you can clearly see the sun going down. There's tons of videos of this. You can see it for yourself. What are you talking about?
Well, I'm talking about perspective.
Mr. Weiss, doing a great job so far. Well, I thought I'd just chime in and give you a hand to answer a few of them difficult questions. And so, here we go with my explanations for you, Mr. Paul. It's like this. You know how the clouds, you can see them on an overcast day, which is a cloudy day like this, and you see them all the way to the horizon. Now you can see that those clouds that are here, the closest ones, they're right above you. Yeah? But you can also see that the ones that are above the horizon are the same height as the ones above you. Just like the telegraph pole gets smaller and smaller, you know the ones at the end are the same height as the ones close to you. So what's this telling you? It's telling you that the same amount of space that's there right above you, from your feet to right above you, the same amount of space is being compressed into the horizon. But not only that, the clouds that are at the horizon, there's clouds below them down all the way to the horizon. So the ones that are the clouds that are the same distance away from you as the horizon is, the clouds that are beneath that, they're further, they're beyond the horizon. So you know that that's being compressed into a smaller area, and therefore you can see further. Now I had someone ask me that question: how can the sun set and the light come under the clouds? Well, it's the same as if I'm standing on my street and I'm looking down my street. If I put my hands above my eyebrows and I cover straight out from my eyebrows, so I can't see the telegraph poles in my immediate area, I can still see the ones at the end of the street. Even though they're the same height and they're above me, I can still see them. And here you see here, as the camera goes down, you lose the horizon. You get less and less distance on the horizon. But the closer you get to the clouds, the more land you see and the less clouds you start to see. The closer you are to the surface, you'll see less of that surface and more of the surface that's further away from you. That is just simple perspective. See how the plane rises and it gets close to the clouds, and as the clouds get closer they get compressed into that small area. And that's why the sun does that, because it's, 6,000 kilometers away? 6 hours, 1,038 miles an hour. There you go. It's 6 hours away. That's why it seems to do that. It seems to plunge into the horizon, but it's not actually doing that. It's just getting further and further away, the same as the clouds are further and further away, yet they're the same height as the ones above you. Yet they're just in a smaller space on the horizon. Now, when the sun is at 12 o'clock, it's right above you. But when it sets, it's 6 hours away from you in a 12-hour day. 6 hours away. So 6,000 miles. Now, if you were halfway between the cloud and the ground, where the cloud and the ground meet on the horizon everywhere around you, 360 degrees, where the cloud and the ground meet at halfway between both the cloud and the ground, the horizon and the ground meet at the exact point of the horizon. The amount of horizon you can see on the ground is the amount of clouds you can see in the sky. Then as you get closer to the cloud, you start to lose the amount of clouds you can see and start to gain the amount of ground you can see, as opposed to the amount of sky. The same as when you're close to the ground. That's how perspective works. It's pretty simple, but you've got to see it from a flat earth perspective as well, which is the way it is. But if you're sitting there saying, oh, well, how can it go behind the horizon? Well, the same way the clouds go behind the horizon. Like, you'd admit they're not as far away as the sun is when it goes behind the horizon on a flat earth model. Well, the clouds are definitely closer, and you can't see them any further. Yet if you're halfway between them, halfway between the ground and the clouds, you can see just as much of both. And for you to be able to see the sun never set, you'd have to be halfway between the sun and the ground. And that's like 2,000 miles if it's 4,000 miles up. And no one's been that high. So that does answer the question. Whether or not you will take it as an answer, who knows? But yeah, that's my answer. And great job, Dave. Keep going.
All right, so we got that. Can I throw one out, or you want to go again?
No, go ahead.
So what causes our seasons?
What causes the seasons? The Earth rotates. It tilts on its axis 365 days a year. It goes around the sun, and it's got certain wobbles too that create ice ages. I brought,
Forget ice ages. I'm talking about 1 year, this year, last year.
Okay,
what caused our 4 seasons?
There's a huge number of factors. It's first of all, we're dealing with the solar system. Okay. You got 365 days a year. You got the Earth slowly tilting on its axis, and that's what causes the seasons. When the Earth's axis is tilted in the northern hemisphere towards the sun, that creates summer in the northern hemisphere. Just like we get summer in the southern hemisphere when the Earth's southern axis is tilted towards the sun. And this cycle happens over 365 days a year as the Earth goes around the sun.
Okay, great. So you're saying that it's the tilt of the Earth that causes the season. So when the southern hemisphere is tilted towards the sun, it's getting more direct rays, and then they're less direct across the top of the ball, and that's why we get our winter, and vice versa 6 months later. Correct?
And that's why southern Argentina has days just as long as our summer days.
We're not talking about the length of the days. We're talking about seasons right now and what causes our seasons.
No,
so you're telling me that
seasons are caused by the length of days. So yes, it's the exact same thing we're talking about.
So it's now the length of the day, not the power of the sun, not the direct angle of the rays. Which one is it? Don't laugh. I'm trying to understand what you're saying so I can respond correctly.
Okay, well, the length of days is caused by the amount of sunlight hitting the surface of the Earth, which is the same thing. You're trying to separate these things. It's like you said before, basically the exact the exact angle the rays are hitting and the area of the Earth that's actually being affected by sunlight is what's causing heating and cooling, which causes winter and summer. I mean,
so hang on. You're saying that it's what's the bigger cause of the temperature, the angle of the rays or the length of the day?
Well, it's both. It's both the angle of the rays and the length of the day, and when it's tilted towards the sun, you get more direct angles and you get longer days.
Okay. So is it we're in an elliptical orbit? Do you believe that, or are we in a circular orbit around the sun?
You know, honestly, I'm told it's an elliptical orbit. Do I know exactly? Okay. No.
All right. So I'll leave that out.
Okay. So I help Dave out with the elliptic orbit question, and he's one of Paul's friends to help us out. He's a globe lover as well, and he's going to explain it to you, and then we'll pick it apart when he's finished.
As we enjoy the lovely mangoes here in India during our summers, we hardly realize that summers are actually longer for us in the northern hemisphere by almost 3 days. Correspondingly, the people living in the southern hemisphere shiver in winters by 3 extra days. Yes, 3 full extra days of winters for Australians. Let's look at the reasons behind this inequality. As we saw in the earlier video, the cause of the season is the tilt of the earth of 23.5 degrees. So at some point in time, when sun's rays fall more directly over northern hemisphere than southern hemisphere, the northern hemisphere has summers while the southern hemisphere has winters. And 6 months later, northern hemispheres will have winters while the southern hemisphere summers when the sun rays are falling directly over the southern hemispheres. But this should mean equally long summers and winters. So where is this 3 extra days of summer coming from? The root cause of this inequality lies in the theory discovered by Johannes Kepler in 1609. In his first law, he showed that the orbit of the earth is slightly elliptical and that the sun is not at the center of an ellipse, but at a slight offset at one of the 2 focuses of the ellipse. What this means is that sun will be closer to sun at some point, which is called the perihelion, and farther at some point, which is called the aphelion. In his second law, Kepler also said that the earth sweeps equal areas in sun's orbit in equal time. It means that to cover equal areas in same interval of time, when earth is far from the sun, it has to travel more distance than when it was closer. So if the earth covers area A at a position far away from sun and it covers area B at a position near to sun, both in the same time interval, then the angle A1 will be less than angle A2. So the earth will travel faster when it is covering area A2. Simply put, the speed of the earth is faster when it's closer to sun and slower when far away. In fact, earth moves at 100,000 kilometers per hour around the sun, and when it is closer to sun, its speed increases by 2,000 kilometers per hour, and similarly slows down by 2,000 kilometers per hour when it is at the farthest. Currently, when the earth is at the farthest at aphelion, its speed slows down. Northern hemisphere is having summers at this time, so the northern summers are longer. Correspondingly, the perihelion or the closest point to the sun happens when the northern hemisphere is enjoying winters. Since the speed of the earth around the sun is faster when we are in northern hemisphere, winters in northern hemisphere will be shorter. And that is why 3 days more. Since the earth orbit is only slightly elliptical, the difference is not that large. And we get to enjoy longer summers by 3 days only. If our orbit would be like Mars, which is around 10% elliptical, the difference between the closest and the farthest point will be much larger, leading to the speed difference which will be much larger, and hence the difference between summers and winters would be much longer, around 25 days.
Whoa, did you just hear your friend there, Paul? Your global buddy. He just said that it goes faster and slower and is closer and further away. Well, for starters, that takes the Goldilocks zone out of the way, doesn't it? It's not about a matter of how close it is it, to determine the seasons? Not at all. And if it's going faster and slower in different parts of its orbit, then it has to be spinning faster to make up, and spinning slower too, to make up for, the distance it's moving, or else it's not going to line up. Well, there's some news for you. More lies about the globe busted.
But by your own model, the sun is at the same distance all the time away. So shouldn't it be just as warm? I mean, if with your theory of winter and summer, if it's still at the same angle, same distance?
No, it's not. It's not. If you look at the flat Earth map, the sun is circling over the Earth around the Tropic of Cancer, which is the inner circle. So it's closer to the normal, to the northern hemisphere. And then as it makes bigger, wider circles, faster circles, higher circles, and the sun actually expands, it is moving at different, it is farther from us. So it's actually a beautifully balanced dance of size, distance, height, and speed.
Okay. There's webcams showing the amount of daylight. You can watch a webcam in Australia right now, and you can tell exactly how much time of sunlight they get during their winter, their summer. And
I will link videos to that because the webcams are edited. They're not consistent. They're all edited, and it's been shown. Jaren from Jarenism has shown many of them. You keep laughing.
All the webcams in Australia and the southern and south of the equator are all edited.
No, well, the video that you used when you did your series on me was you showed the Antarctic sun. I mean, you actually believe that is a real sun with those big spindles on it perfectly going around? I mean, you believe that's a real video?
Well, I know that they used After Effects to overlay and put some stuff behind it. But yeah, I believe the video is authentic, yes.
Well, how did they prove it thousands of years ago? Are you talking about Aristophanes?
Yeah, I don't want to waste time with that. Everybody knows the story. You guys love to go on and on about it. You're going to just burn probably 20 minutes talking about the well.
Well.
I love it. Well. I won't talk about the well. Well. Anyway. Well, yeah. We've all seen the footage, and it's obvious that he doesn't want to talk about it because it's one of the things that just stands out. Eratosthenes, he apparently measured the Earth using shadows, and apparently he measured it because he was able to say that the sun's rays enter the Earth at parallel lines, and therefore he could go 500 kilometers or miles or whatever apart and measure it by the shadows and timesing it by 50 or whatever. And that's just bull. Anyone who can see, fortunate people like us who use their eyes, have seen the sun coming through the clouds, and you can see that the light's rays spread out, they fan out, they splay across like a dove's tail. We've all seen it. So how did Eratosthenes measure the Earth using parallel lines when we've all seen the shadows come? We've seen them go right across the plane. I've got a video there that shows it, just fully calling Eratosthenes out. And man, how can you guys, keep going on about proof when you don't have any proof? There's no proof for the globe at all. And that one there, that's why you don't want to touch it at all, Paul, because you know that it just blows it out of the water, mate. You know that there's no way you can beat it, because what we see and what you use for your proof clash. And yeah, it is amazing that no one's asked about it, and that's just, the way it is. But we're asking now. So, I wonder if you've got any more proofs. I don't remember you having too many more, but I'll listen on and see if there's anything else I can help Dave out with.
So great. So that leads me to my question. A little experiment that you can do that should, if with critical thinking, dismay that belief is get a bottle, like a 64-ounce bottle. Hopefully it wasn't from soda that you drank. Suck the air out of it, just like half of the air out of it, so it doesn't crush. And put the top on, and we'll call that a vacuum. But because there's some air in there, we'll call it a lesser vacuum, lesser than the gravity, than the total vacuum of space. Now, if I poked a hole in the bottom of that bottle, air would get sucked up into it, up away from gravity. Better yet, if I stuck the bottom of that bottle inside of water and I poked a hole in it, it would actually lift the water up into it, which is, I think we could agree, heavier than air. How come gravity, which is stronger, closer to the Earth, doesn't hold that air and water down?
It's called pressure, something called air pressure.
Air pressure. There's no air pressure in the bottle. We have a vacuum, and that vacuum is able to lift up water away from gravity. And you're telling me that the greater vacuum of space can't pull the weaker gravitationally held air that's velcroed to the Earth through gravitrons that's spinning with the Earth at incredible speeds. How is that even possible, Paul?
Well, if you have a soda bottle, like you've driven in your car where you're at a low altitude, and you got a soda bottle that's kind of compacted, and you go to a higher altitude, the bottle expands and you hear a soda bottle popping. It's because
Sure.
of air pressure changed. You got lower air pressure versus higher air pressure.
That has nothing to do with the question that I'm asking you. If you're saying that gravity holds the atmosphere to the Earth and the vacuum of space can't pull it away, you even said that the gravity is higher. I'll even say that it's equal all the way up, just to make it that much harder for the vacuum to rip the atmosphere off the Earth. How come I can suck water up with just a little bit of a vacuum, a way lesser vacuum? Probably
Because you
2%.
created a low pressure system in a straw.
Okay, so there's a low pressure system in space. Space is the ultimate low pressure system. How come it doesn't suck the higher pressure of the atmosphere of Earth off the surface?
It's, gas, like anything, has a density and it has a weight. So it's being pulled down to the surface, and then you got a certain air pressure. I mean,
Your explanation, you said that gravity held the air to the
why
Earth.
isn't the atmosphere being sucked out into space? I think it's just being held in by gravity.
All right, but how come a lesser vacuum, a less powerful force than the vacuum of space, can lift water and air away from the most powerful gravity? You know what? Everybody, think for yourselves. Move on. Next.
Okay. Okay.
I'm not going to listen,
okay.
Paul.
Okay.
You're digging a
No,
hole
no.
for yourself because you're not thinking about it. So think about it, and then you can respond. All right?
Well, I'm thinking if you climb a mountain, the atmosphere gets thinner and thinner until there basically isn't any, and that creates a frictionless environment, perfect for a solar system or some sort of, exactly what you would expect. But you're saying the atmosphere doesn't get thinner as you go up?
No, I'm saying it does get thinner, but what's stopping it from getting ripped off into the vacuum of space? You have to have a border. Never can you ever have a high pressure and low pressure system that the high pressure won't go to the low pressure unless there's a barrier.
Okay. So the Bedford level experiment, I guess they can't repeat that, huh?
Nice one, Dave. Nice one. Mate, that was brilliant. That was awesome. I love how he's just, okay. So the Bedford level experiment. He just move on. Too hard basket. Mate, come on. Why is he laughing at you? Well, he's the joke. Can't answer anything. You just go, well, let's just move on and let's just avoid it all. Yeah, typical.
Next.
Okay, well, so they can't.
I got
can't
one for
repeat
you.
the Bedford level experiment.
Well, you say that they can't. Who couldn't do it?
Well, I looked all over the internet for it being
Well,
repeated.
how come you haven't done it? Why don't you do it and prove us wrong?
Here's the thing. I can't prove you wrong. There's tons of videos of boats sailing over the freaking horizon.
Again,
There's tons
that
of videos.
again, that is the you're right. There are videos of that, and there's also videos of boats going over the horizon, and then you get out a super zoom camera, and boom, there's the entire boat again. But you have to remember,
No, that's not true. Okay.
it is true.
No.
It is true. It is true to a point. To a point where you can't see the boat anymore.
And then the
because
atmosphere. Yeah. Then you get light reflection, you get actual bending of the atmosphere, and you get the thicker atmosphere, and that's exactly what you should expect to see. But if you look for sailboat going over the horizon, people, do a search. You clearly see the bottom and could disappear first, and then slowly the sail goes behind, and just do a search.
So as you look farther, you're looking your angle to the water is getting closer and closer to zero. We've all seen, or most of us have, that a boat on a very calm day, as it's going farther and farther out, it kind of looks like it's floating into the air, but we know that's just a mirage where we're seeing the sky and the water. It's not floating in the air. It's going across a flat plane, but due to the way our eyes work, perspective, refraction, all of those things combined make things disappear. I have lots of videos, which I will be linking on here. This is the one thing that takes the most amount of time and intense thought to understand. And truly, there's probably a few parts of it that I don't even get yet, but there's plenty to show how things disappear over or past the vanishing point. Over horizon, I say past the vanishing point.
Yeah, this one's pretty easy. If things are going over the horizon, it has to be due to perspective, because we can only see 3 miles, 6 miles, or whatever it is to the horizon, and we can see way more than that of horizon, left and right. So how come we don't see that curve? If we see the curve starting at 3 miles or 6 miles or whatever it is in front of us, then we don't see it going sideways over 50 miles. 25 either side of us. I go to the beach down here, I'm in a huge bay, and I have a city which is there, and it's about 30 k's to the city. I can see the city. I can see the bottom of the city, and I can see way out to sea, and I can see way up the coast the other way. So when I can see all the horizon, just horizon, I can see at least 50 mile of horizon, but I don't see any curve, I only see it flat. So that's a pretty easy one, that one. It's hard to explain, but it's what we see. Yes, we see things go over the horizon due to perspective, but it's such a short distance compared to how much horizon we can see in one given span of horizon, and we don't see any curve. Simple.
Let's get back to flat Earth or ball Earth proofs. Show me that we live on a spinning ball. What else do you have? Is that it? I mean, everything that you have goes to the same
lunar
question.
and solar eclipses. Okay, you got the sun that's behind the Earth, and the moon passes. In between. The Earth is between the sun and the moon, and then you get the shadow of the Earth on the moon. I believe Patricia Steer made up some weird, fake planet name that's an invisible planet that's in between that's causing the moon to have a.
I don't believe Patricia Steer made that. Eric Dubay talked about it, and many other people talked about it.
So it's an invisible planet.
No, it's not. You know what? I don't even know what that is. But there's been many eclipses where the sun and the moon are above the horizon during the eclipse, and that's just impossible. That's impossible.
There hasn't been any eclipses where the sun and the moon are above the. No.
There's been over 50 documented ones. And here I'm going to actually share an image. Continue.
No, this is groundbreaking. Please share.
Well, here's the question.
I've never seen an eclipse where both the sun and the moon were above the horizon. Please share.
Am I on?
Yes.
Am I on?
Shush.
So it's December 10th, about 6:30 in the morning. It's about 18 degrees out here, and we're standing on top of Cahokia Mounds, just east of St. Louis. Behind me is a full moon, which will soon be going into a full lunar eclipse as it sets, kind of a rare experience, while at the same time behind us, the sun is already beginning to rise. So this could be a very interesting and beautiful experience. Oh, am I on? So it's about 6:55, and as you can see, we're getting a little bit brighter out here. You can see the shadow creeping across the moon. It's a little hard to see, I'm sure, in the camera, but from here we can see it nice and clearly. It's about a third of the way covered. The moon's starting to turn nice and orange. Over my right shoulder, you can see downtown St. Louis and the nice early morning sun, which is getting very bright on the eastern horizon behind us. Yeah, we'll get that in there again. You can see it's practically day here, yet we still have the full moon out, which is slowly eclipsing. And it's still cold. Okay, so it's now about 7:04 a.m. and over my shoulder you probably cannot see anything, but through the stacks of the refinery back there we can just barely make out a little bit of the moon left. It's about 2/3 the way covered with earth shadow, and it's turning a sort of pale orange pinkish color, but with the bright morning sun coming up, there's not enough contrast to be able to see the moon there. We can still see it just a little bit. What I find very interesting is I was expecting the shadow to come upward across the moon as it would go down and it would pass into shadow, and actually it's going the other way around. The shadow, as the moon is here, the shadow is creeping down across the moon, even though the sun's coming up over here, and that must be because of the moon's rotation around the earth. It's moving farther up, even though the sun's light is actually coming from over there. It's actually coming underneath the earth. So if you imagine the sun is here, the earth is here, and the moon is back here, and the light was coming under the earth, but the moon must be rotating around even though we're turning, so it looks like the moon is going down. It's kind of an optical illusion. It's pretty cool. So the sun is scheduled to set at 7:08. I'm sorry, the sun will rise at 7:08. The moon is scheduled to set at 7:08. So exact same time, so we might actually catch a glimpse of both for a brief moment as the moon is disappearing.
Living there, you'll be free if you truly wish to be.
There you go. An eclipse with both sun and moon above the horizon. But what I love is the way he tries to explain it. And tries to explain the light coming under the earth while the moon's above the horizon and so is the sun. Just doesn't make any sense either. But that's just the normal bull jargon for you. And basically that's all he seems to have. He just goes on asking the same old questions over and over again, does old Paul. And yeah, he's another one of his friends here, one of his glow ball friends, who's pointed out another problem he can't seem to understand. He's solved it for him. Quite funny, I think. Well, Dave, I think you did an absolutely great job, my friend. You're a beautiful bloke. You're nice, you're kind, you're respectful, you have a lot of insight. People will take a bit of advantage of you and ask you 100 questions at once. And, yeah, but you do well. You hold your own very well. I hope you don't mind me doing this bit of narration and helping you out a little bit here. I just noticed that he sort of ran around you a little bit and didn't really let you get your say in. And yeah, he got you a bit flustered and upset, and it's not easy to work under those chilly sort of conditions. But anyway, yeah, it's funny how the pots keep calling the kettle black, and we keep finding out that, yeah, they're just as black as, if not blacker. Well, definitely blacker. Yeah, so I can't believe his statement that we work for NASA myself. We work for NASA, just proving NASA, and what is to take people's attention away from what NASA's doing. If anything, we're focusing attention on NASA. So yeah, I don't see where you get your logic from there, Paul. But anyway, I don't mind your videos. I have watched them a few times, but yeah, I don't sub to you. You're not that good. It's good to watch you because you watch a lot of flat earth videos, and that's obvious, especially when you know Dave wore the same shirt 2 days in a row. Far out, I don't watch that much flat earth videos to notice what he was wearing yesterday. Mate, you are up to date. Well, anyway, for someone who doesn't like the flat earth, you just like all the trolls and everything, you just can't get away from the flat earth. It's a strange thing, but I believe that, yeah, that sort of just makes you guys stand out, you know, stand out for what you are, because no one in their right mind would go and hang out somewhere. Like, it's like, do you Google the mental asylum? Do you like try and solve their problems for them? Because like there's a lot of people in there that are very delusional and have some crazy ideas, and they need actual genuine help. And yeah, but maybe you don't want to go near those places. Maybe you escape from one of them. Well, we all did actually. Well, us flat earthers, we escaped from the mental asylum you're still living in. But anyway, I'm glad I could help Dave and Paul. I hope you wake up and smell the jara. Get a good whiff of it, and I don't know, drop this whatever you're doing and just like, I don't know, stop lying, stop psyoping, stop shilling, stop whatever you're doing, because you're not getting anywhere. And if anything, you're doing a benefit for the flat earth. But yeah, the way you do it, yeah, it's not very nice, because yeah, you don't really let people have a civil, nice conversation. You treat it like a joke, just because you're like a clown like that. What's his name? Your mate Jaren debated him. Was it Jeff C? Yeah, JC the clown. That's the one. Yeah, mate. You're probably friends with him already. Come from the same circus, and yeah. Well, anyway, you both belong in the same place, because you seem to be pushing the same thing and not listening to any logical reason. But we're getting used to that. And anyway, I hope I could help again, Dave. And yeah, another good video, mate. Keep it up. You're a pioneer, mate. A great pioneer. Yeah, thank you to all you genuine flat earthers out there that are pushing truth, real truth. This is the time. This is the veil, and it's been lifted. It's got lifted. Okay. Thank you all again for listening, and I hope you've all learnt something, and I hope you can all jump on board the flat earth and wake up to the global lie. Okay. God bless you, everyone, and bye.
left your heart in a Portland